Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about subordinate response and signal and what is the transfer type when you are in idle state and what should be the transfer type when you are in weighted states and what should be your transfer types when you are in a weighted state, like what should be the busy transfer. Everything we are going to discuss in this particular session. So let's start discussing about this particular subordinate response signaling. So we have already seen this subordinate response signaling, like we have a master and a slave. So we have a master and a slave where your master is going to send some response data and address signals. So the master sends us the address signal and the data signal like HW data. So for this particular address and data signals, the slave should respond for that particular transfer. If it is a write transfer, the slave should respond to that particular transfer by providing the corresponding H response signals. So if your H response is equal to 0, then that means the slave is sending a OK response. That means the transfer has completed successfully. That means that the transfer has completed successfully. So OK, that means the transfer has either completed successfully or additional cycles are required for the subordinate to complete the request. So this is nothing but our OK response. So the transfer has either completed successfully or additional cycles are required for the subordinate to complete the request. This is when it is happening. It is when HTD is equal to 0. That we will see. So the HTD signals indicate whether the transfer is pending or complete. And coming to whenever your H response is equal to 1, that means your response is an error response. That means an error has occurred during the transfer and the error condition must be signaled to the manager so that it is aware that the transfer has unsuccessful. So the master, how is going to know that whether the transfer has not completed successfully or not? So by sampling this response signal which was given by the slave, the master will come to know that okay, the transfer has not successfully completed, so it will come to know that there is an error in the transfer. So that like that the master will come to know. So a 2-cycle response is required for an error condition with H radio being asserted in second cycle. So first what is going to happen? First the H response signal will be made to 1. Then the HTD out signal will be made to 0 because then the HTD out signal will be made to 1, so that the response which was given by the slave, which is a valid response. So using this H response signal, the master will come to know that whether the transaction has successfully completed or not yet complete. Let us try to understand the transfer type during the weighted state. So whenever your HTD is equal to 0, let us try to understand the behavior of our transfer type. So during an idle transfer, that is our H trans is equal to 0, 0. So let's say our H trans in our transaction is equal to 0, 0. Let's say our H trans is equal to 0, 0. And we have a weighted state. Weighted state, that means HTD is equal to 0. So during a weighted transfer, the manager, it is permitted to change the address from idle transfers. So when the H transfer type changes to non-sequential, the manager must keep the address constant until HTD is high. So let's see what is this. So here we can see in the T0 to T1 cycle, our HTD is equal to 1. In the T0 to T1 cycle, our HTD is equal to 1. So the transfer type also we can see it is non-sequential. And the address the master is providing is address A. Let's say address A, and the H burst is single burst. Okay. So this is the thing which the master is providing. Now in the T1 to T2 clock cycle, we can see the transfer type is idle. In the T1 to T2 clock cycle, we can see the transfer type is idle. And what about the address? It is Y. Okay, it is Y. And we can see here H ready, it is equal to 0. We can see here in the T1 to T2 clock cycle, H ready is equal to 0. H ready is equal to 0. That means in our very first sessions when we were discussing about weighted transfers, we have already seen that The master is not allowed to change any data signals, address signals and control signals whenever your H ready is equal to 0. This is the point we have discussed in the very first session during the weighted transfers. If you haven't watched those particular sessions, please go back and rewatch those sessions, which are available in the playlist of AMBA AHB 2 playlist. Okay, now, so what is the thing is, once again I will repeat it, whenever your H ready is equal to 0, the master is not allowed to change the transfer type or any other control signal, address signal, data signal. This is the rule which we have studied in the previous sessions, but there is an exception here. What is the exception is, whenever your H ready is equal to 0 and whenever your transfer type is idle, you are allowed, the master is allowed to change the address during the weighted state. Here you can see in the T2 to T3 clock cycle also our H ready is equal to 0. In T2 to T3 clock cycle also our H ready is equal to 0 and the transfer type is idle. Since although the transfer type is idle, but the H address is changing. So see here, although the H ready is equal to 0, the transfer type is idle, but the address is getting changed. See, so Y, the second address in the T1 to T2 clock cycle, the address is Y, and in the T2 to T3 clock cycle, the address is Z. Okay, but previously what we have studied, the transfer type and any other address signals or the control signal should not change whenever your H ready is equal to 0. But there is an exception. What is the exception? Is whenever your transfer type is in idle and whenever your H ready is equal to 0, you are allowed to change the address. That is from one address to another address. So this is what it is written here. During a weighted transfer, the manager is permitted to change the address for idle transfers. The manager is permitted to change the addresses for idle transfers. Now, when transfer type changes to non-sequential, let's say in T2 to T3 clock cycle, it is idle, and T3 to T4, the transfer type is getting changed to non-sequential. Now, here is one more point to be remembered is whenever your H ready is equal to 0, the master is allowed to change the transfer type from idle to non-sequential. It is allowed to change the transfer type from idle to non-sequential. So this is one more rule. So what we have studied previously, that master is not allowed to change any address signal, any control signal, any transfer type. It is not allowed to change during the H ready whenever H ready is equal to 0. But if your H ready is equal to 0 and whenever you have an idle transfer, you are allowed to change the transfer type from idle to non-sequential. And what is the second rule we have? Whenever your H ready is equal to 0 and whenever your your transfer type is in idle transfer, you are allowed to change your addresses. So that's why we can see here, whenever you are in idle transfers, the master is able to change the addresses. Now, whenever the idle transfer transfer type changes to idle to non-sequential during the H ready is equal to 0, then what is happening? Then our H address has got a constant value, that is B, and our burst, it is INCR4, and you can see in the T3 to T4 clock cycle, there is no change in address and there is no change in any control signal. And in the T4 to T5 clock cycle also, it is a weighted state, that is your H ready is equal to 0. There is no change in the transfer type or control signal or any other signal. But whenever your H ready is equal to 1, then only in the next cycle there is a change in the transfer type and there is a change in the address, and if you want, you can change the burst also. Okay, so we should remember one thing is, we should remember basically 3 points. What is the first point? Is whenever your H ready is equal to 0 and your transfer type is idle transfer, then the master is allowed to change the addresses. Whenever your H ready is equal to 0 and transfer type is idle, the master is allowed to change the addresses. What is the second point? The second point is whenever your H ready is equal to 0, the master is allowed to change the transfer type from idle to non-sequential, and if this transfer type has changed to non-sequential, it should be kept constant until the H ready becomes high. Okay, so this is the point which we have written here. So whenever your transfer type changes to non-sequential, the manager must keep the address constant until H ready is high. And what is one more thing here, whenever the transfer type has changed to non-sequential, your master is not allowed to change the address in that particular transfer type. So that is what it is happening. Okay, so this is nothing but address changes during a weighted transfer. Now let us see the second scenario here. Let us see the second scenario where here in the T0 to T1 clock cycle we have the transfer type as sequential and H address as some starting address 24 and H burst is INCR4. This is very important to be understood. H burst is INCR4. It is a increment 4 burst. Okay, and HAD is equal to high during the T0 to T1 clock cycle. HAD is equal to high during the T0 to T1 clock cycle. H address is 24 and H trans is equal to sequential. Now in the T1 to T2 clock cycle, if we can see, the transfer type is busy and your HAD is equal to 0. Your HAD is equal to 0 and your transfer type is also busy. Now whenever you have this busy transfer type and your HAD is equal to 0, whenever your HAD is equal to 0, now this HAD is 0 up to T3 clock cycle. This HAD is equal to 0 up to T3 clock cycle, and we have the transfer type as busy, and in the T3 to T4 also HAD is equal to 0. Now in the T3 to T4, whenever your HAD is equal to 0, the master is allowed to change the transfer type from busy to sequential. Okay, so whenever your HAD is equal to 0, the master is allowed to change the transfer type from busy to sequential, and if it has changed to sequential, it should be kept a sequential. It should not change the transfer type. It should not change the transfer type, and if it wants, it can go back again to busy, and it should come back to sequential only. Okay, so whenever your HAD is equal to 0, the master is allowed to change that only the transfer type, not the address also. Okay, I will write down here. Whenever your HAD is equal to 0, the master is allowed to change the transfer type from busy to sequential, and again sequential to busy if it wants. Okay, whenever this your HAD is equal to 0, and you should also not change your address and any other control signals apart from this H trans. So this is the second scenario. Now coming to third scenario, where this third scenario is nothing but busy transfer undefined length burst. So during a weighted transfer for an undefined length burst INCR, the manager is permitted to change the busy to any other transfer type. So during a weighted transfer in an undefined length burst, this is very important to be understood. Previously we have seen INCR4, but here it is an undefined length burst, that is burst is equal to INCR. Okay, and whenever your HAD is equal to 0, whenever your HAD is equal to 0 and the burst is INCR, then the manager is permitted to change the busy transfer to any other transfer type. So the manager is allowed to change the transfer type from busy to, it may change it to non-sequential, or it may be changing it to sequential, or it may be changing it to idle. And one more catch, if you've seen, it is an undefined length burst, and many of you having this particular question, when we have discussed the undefined length burst in our previous sessions, you might have got this particular doubt. Let us clear that particular doubt with this example. We have a manager and a slave like this. Okay, and let's say if the manager is performing a write operation, that is write is equal to 1, and let's say it is an INCR burst, and let's say it is an INCR burst. What do you mean by INCR burst? INCR burst is nothing but it is a undefined length burst. INCR burst is nothing but it is an undefined length burst. Now what do you mean by undefined length burst? Undefined length burst means we don't know how many number of packets we are going to send, or we don't know how many number of packets we are going to receive in the case of read operation. Okay, now how will slave will come to know what is the number of beats the master is expecting, because there is no number of beat mentioned here, it is just simply INCR. Okay, so this might have a doubt for many of you. So let us try to clear it. So here we have an INCR, that means undefined length burst. That means during the first address phase, so during some addresses, let's say this is T1, this is our clock cycle. So this is our T1 cycle and T2 cycle and T3 cycle. So in the T1 cycle, we can see let's say the master has started this INCR, and the transfer type, let's say it is kept to non-sequential, because it is the first address, first packet. And in the second packet, what it will do, it will give sequential. The transfer type, it will give it as sequential. And for third bit, the master will do sequential. Now let's say if the master has decided to stop the transfer, okay, now what it will do, it will stop the transfer. And how will the slave will come to know? Because there is no number of beats mentioned here, so the slave can stop anytime. Now how the slave will come to know? So the master will tell the slave using this H trans signal. So what it is going to do, it will change the sequence, it will change the transfer type from sequential to idle. It will change the transfer type from sequential to idle, so that the slave will come to know, okay, the master has completed the transfer. By sampling this transfer type, the slave is going to come to know that the master has completed the transfer. Or let's say if the master wants to stop the transfer after 6 bits, because it is an undefined length burst, it may send the number of beats the master is going to send is undefined by the slave. Is not the slave don't know how many bits it is going to receive or how many bits it need to send. How the slave will come to, then how the master and slave are going to be synchronized? Using this H trans signal. So let's say after 6 number of bits, if the master wants to stop the transfer, it will change the transfer type from sequential to idle, or it will change the transfer type from sequential to non-sequential. If it is changing the sequence, if it is changing the transfer type from sequential to idle, that means the transfer has entirely completed. It is the master is entering into idle state. But if the master is changing the transfer type from sequential to non-sequential, if it is master is changing the transfer type from sequential to non-sequential, that means the present transfer has completed and it is going to start a new transfer, because non-sequential is standing for new transfer. If you haven't watched the transfer type videos, please go back and rewatch it. So there we have discussed what do you mean by non-sequential and what do you mean by sequential. Okay. So here if the master wants to start a fresh transaction, what it is going to do, it is going to change the sequence to non-sequential. If we are getting non-sequential, then the slave will come to know that, okay, present transfer has completed, the master has started a new transfer. So like this, the master and the slave are going to be synchronized with each other whenever we are having a undefined length burst. Because in the previous bursts where we have INCR 4 or RAP 4, we have a beat number 4 or 8, okay, but in the case of undefined length burst, we don't know how many beats the master and slave are going to communicate with each other. Okay, so that's why using this transfer type, the master and slave are going to be synchronized with each other. So this is the way they are going to be synchronized with each other. Now coming to this INCR, whenever your H ready is equal to 0, so the manager is permitted to change the busy to any other transfer type. During only this condition, whenever your INCR and H ready is equal to 0, the manager is allowed to change the transfer type from busy to non-sequential, busy to sequential, and busy to idle. So the master is allowed to change the transfer type from busy to non-sequential, busy to sequential, or busy to idle whenever it is a INCR burst and H ready is equal to 0. Let's say if the master is changing the transfer type from busy to non-sequential, what it means? The present transfer has completed. If the master is changing it to the non-sequential, that means it is starting a very new transfer. The present transfer has completed, it is starting a new transfer. Okay, and if the master is changing the busy to sequential, that is, it is continuing the same transfer. Same transfer has not yet completed. And if the master is changing the transfer type from busy to idle, then also in this particular case, it is the present transfer has completed. We don't know about the new transfer, but present transfer has successfully completed if the master changes the busy transfer to idle. So this is how the master can change the transfer type from busy to any other sequential types, any other transfer types, and this is the meaning if the master changes to any one of the transfer type during the undefined length burst. HRD is equal to 0. Let us see this with a waveform. So during the T0 to T1 cycle, whenever your H trans is equal to sequential and your H address is equal to some value we have, okay, and H burst is equal to INCR. INCR means undefined length burst, and your HRD is equal to 1, okay, in this particular cycle. Now in the T1 to T2 clock cycle, our transfer type is busy, and in the T2 to T3 clock cycle also our transfer type is also busy, okay, and our address has some value, and we have a undefined length burst, and our HRD is equal to 0 up to T3 clock cycle. Now in the T3 to T4 clock cycle, if you see carefully, the transfer type is getting changed from busy to non-sequential, because the master is allowed to change the transfer type from busy to any other transfer type during whenever your HRD is equal to 0 and your H burst is INCR, okay, whenever your H burst is INCR, and the master is also allowed to change the burst also. It is changing the burst from INCR to INCR4. It is allowed to change the burst from INCR to INCR4. And you can see there is a completely new address and it is a new transfer, and if it has changed to new transfer type, new address and new burst, it should not change that particular values until your HRD becomes 1. If your HRD is becoming 1, then in the next cycle the master is allowed to change those values. And you cannot change the burst immediately because it is an INCR4 burst rate, so you need to first complete the 4 number of bits and then you can change the burst. So this is how your master is going to change the transfer types and change the burst and change the addresses during the weighted transfer. So that's all about this particular video. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.